Okay, we are talking about lesson 6.7 and 6.8 here. We are going to be talking about simplifying common logarithms. We're going to be talking about using the change of base formula so that we can simplify any logarithm that shows up. And then we are also going to go back to our interest problems, and we're going to be calculating continuous interest. So 6.7, I believe, is over 1 of these common logarithms, and 6.8 is over 2. So we're just going to combine those together. So what are these simple logarithms that we're talking about? Well, there is a log of x, and if you guys look at your calculator, you guys will see that there is a log button. It's a button that just says log. So some of you guys might have tried to use that log button to answer some of those questions and then found that it is not possible. It doesn't work that way. So log of x, you might notice there is no base. Well, this is the second most common logarithm, so they just don't write that base down. Log of x is actually a log base 10 of x. So if you ever see a log without a base written there, if you ever see a log without a base written there, that means that it is a log base 10. Okay, and that is the second most common logarithm. The most common logarithm is this ln of x, this ln of x. This is called the natural logarithm. It's our natural logarithmic function. Okay, and if you ever see an ln of x, what that actually means is this is a log base e of x. A log base e of x. And this also has a button on a calculator allowing to solve for it. So the first thing you guys should notice is we have this log base e. So what is e? What is e? Well, we're going to watch a video here real quick. As you guys are watching this video, the link's here if you want to watch it on your own computer. I want you guys to be able to answer the question, what does e equal? Who discovered e? And then what all is e used for? So we're going to go ahead and watch that YouTube video here.
We made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli. But later, Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So, if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
The number pi is equal to 3.1415926.
Okay, so hopefully you guys got this stuff filled in. What is E? The approximation that I have always seen for E, whoops, let me write it with my other pen here. The approximation I have always seen for E is 2.71. It's actually 2.718. I don't know why they don't round up, but I've always seen 2.71 used for E. There is a button on your calculator. Okay, if you guys look at the ln button on your calculator up above that in green, you will see an e to the x power. So you'd have to hit second and then hit that ln, and then that would be how you get your e button to pop up for you. Who discovered e? Well, that would be Jacob Bernoulli, who initially, gave it its value. And then it was Leonard Euler who actually defined it and said that it was E. And I don't know if you guys picked up on this when you were watching it, but E and pi are kind of like the same thing. And they're not at all like the same number, but they are both an example of some irrational number that mathematicians, scientists basically kept seeing pop up over and over again when they were looking at things. So that caused them to start looking in more detail at those numbers and trying to define them for as many variables as they can. So these are just naturally occurring irrational numbers that kept popping up. Pi showed up in circles. That's where we ended up defining pi. And E showed up in our compound interest, which we talked about last time, or a few times ago. Okay, and our compound interest was that A equals P times 1 plus R over N to the NT power. Basically, they started figuring out that this value in here could be E. So we're going to do a different interest. It's not compound interest, it's continuous interest. And your continuous interest formula will be your principal, P. But then instead of figuring out this rate, you've got an E in there when you're looking at that rate. Okay, so what is E used for? It's used to figure out interest at banks. In statistics, it's used for your normal distribution. If you guys have not taken a statistics class, you probably will if you end up going to college. Your normal distribution basically is a way that they define any sort of stats. Normal distribution is huge. It's called the bell curve. Basically says that you find your average and then 50% has to be over here and 50% has to be over there. We'll do some stuff with normal distribution at the end of the year probably. Bio, they use it to look at population growth. And we've seen that when we did these word problems. We looked at the population growth in humans. Okay, and then also in your physics, it can be used for your exponential decay. And we kind of had a problem like that where you have material and the materials have half-lives. Okay, usually when they are looking at exponential decay, they are looking at E when they are looking at those examples there. Okay, so E, I get a lot of questions, when will I ever use this? E is a huge one that is used in a lot of real-life situations. Might not be one that you have in your real life, but people are using E all the time in a lot of different ways. So why are we going over these common logarithms? Well, you are going to be able to simplify these common logarithms. Now, since you do have a button on your calculator, if I give you an ln of any number, so ln of 2, we can't cancel anything with an ln of 2 because remember your ln, that's actually a log base E of 2. So these bases don't match, so I can't simplify this. However, now I have a calculator that I can use because there is an ln button on my calculator. So if I wanted to here, I can simply hit the ln button, and when you hit the ln button, a parenthesis is going to pop up, and I can plug in ln of 2. And I can see that ln of 2 equals 0.69314, and I can round it there. Okay? So now with ln, we are going to be able to use our calculators to simplify these things. Okay? Now, with that being said, yes, we can use that. We should still be trying to simplify these without calculators. So a very simple one, I have ln of E. Remember that your ln function is actually a log base E of E. So what do I notice about these two here? Well, those two bases match. Those two bases match, which means if their bases match, I can cancel them. Okay, and what do I have left? Well, if that's just an E, that's an E to the first power. So that means I have a 1 left over. Now, you do not need to show this step. In fact, I would prefer it if you didn't. What I would prefer is you guys to be able to look at ln and E and say, oh yeah, ln and E are inverses of each other, so therefore they cancel. And my answer is 1, because that's an E to the first power. Okay? The same could be said for this example down here. I've got E to the ln of 3. Okay, so this is our flipped version of it, but once again, I see E and I see ln. Remember, ln is a log base E, So their bases match. Those two things would cancel, and all that I'm left with is that 3. So e to the ln of 3 power, e and ln cancel, and I'm left with 3. Okay? Another example here, I've got ln to the 1 over e. Hopefully you guys remember from 6.4 part 2. When we see fractions, we should be thinking negative exponents. How did that e get to the bottom there? Well, that would have to involve a negative exponent. If I move that back up, this ends up becoming an ln of e to the negative 1. Ln and e have the same base, so therefore we can cancel those. Leaves me with my final answer of negative 1. Okay, so we can use a calculator when solving these ln's. However, we should still be able to simplify them without using our calculators. And in fact, on your test, you will be asked to do that as well. Okay, the second most common type of logarithms, remember, if you ever see something that is just a log of x, that actually means log base 10 of x. They just don't write that base down there. Okay, so here I've got a log of 5. So log of 5, that's a log base 10 of 5. Those bases, they don't match, okay? And although 10 and 5 are related, you cannot get 5 to be 10 or 10 to be 5 with any sort of exponent. So we can't simplify that there. But we can use our calculators to simplify these. So for this one, I'm just going to hit my log button. And again, log with a parentheses will pop up. Plug a 5 in there, and I press enter. And this problem, using my calculator, I can see that it equals 0.69897. So really I can just round that up. 0.699. Okay. I believe when you guys are doing your homework, I tell you guys to round it to 4 decimal places. I didn't do that there, sorry. But anyway, so you can use your calculator with these logarithms. However, once again, you are going to be expected to do this without one. So if I have a log of 100, remember that's a log base 10 of 100, I need to get their bases to match. Well, 100 is the same thing as 10 squared. So now I've got a log base 10 of 10 squared. Now their bases are matching each other, so I can cancel those, and I would be left with 2 for my answer. Again, you don't have to show this step with a base 10. You can simply look at it, log of 10. Well, remember that's a 10 to the first power. I know that if I just see a log, it's a base 10, so those cancel, and I'm left with 1. Same thing here, 10 to the log of 6. It doesn't say the base. If it doesn't say the base, then we know that the base is 10, so these two bases would match, and I'm left with 6 for my answers. Okay? So log and ln, two most common types of logarithms. Ln, remember, is log base e. Just a log of x is actually log base 10. There are buttons on your calculators to help you simplify those. And in the next slide, we are going to talk about how this ln and log, how we're going to use our calculators to simplify any logarithm. I'll be able to give you guys a log base 2 of 3, and you can simplify that and tell me exactly what it is.